Thank you all for joining us today. I'm Dirisha Kurtipuri, the director of the Matrix AI Consortium. Some of you are already working on different activities with Matrix. Today, we are going to bring you two AI research scientists, Dr. Janan Shai and Dr. Hina Rathore, who are going to give a basic introduction to some of the AI concepts. Some of you might be at an advanced stage, but some of you might be at the introductory level and would like to know a few basic concepts. So we are going to do a series of these AI tinkering with the AI scientists. So this is just the first of these series, and we were actually hoping we could do this in person and have more hands-on experience for you. But given the current situation, Dr. Chai and Dr. Rathore were very graceful to do this experience, even though it's virtual. So both of them are the core members of Matrix, and they're engaged in a lot of educational activities and outreach activities in the AI space, coming from very different backgrounds. So I think you'll have fun learning things from them today. They're great researchers, and they're passionate about bringing that experience to you. So our first presenter today is Dr. Janan Shai. And I think, Janan, is it okay if they ask you questions during the session, or you want them to wait?
Oh, of course, no problem. They can answer during the session.
Yeah. So this is a very interactive session,
yes.
So feel free to ask questions as they come through. So hope you enjoy it. The floor is yours, Janan.
Thank you, Dirisha. Let me share my screen. Can you see my screen?
Yes.
Okay, thank you. So hello, everyone. Thank you for attending this event. And my presentation is, I will give you some brief introduction and help you to get you familiar with deep learning in computer vision. And first of all, let me introduce myself and my research that is related to this topic. So I'm an assistant professor in Department of Construction Science, and I just joined UTIC last year. And my research interest is automation and robotics in construction, artificial intelligence and computer vision, and several physical systems with applications in construction and civil infrastructure. And one of my research that is related to our topic today is a series data-driven approaches and deep learning method that I developed to achieve holistic situational awareness in complex workspaces. And as many of you may know that, and you may see in your daily life, that construction site is very dynamic and complex workspaces where there are multiple workers and machines interact with each other and in some collaborative construction activities. And my research is to automatically understand this scenario from visual data, so construction videos, in order to know where the workers and equipment are, what are they doing, where will they go, such that we can proactively identify potential hazards or safety issues, and we can also analyze the productivity. And these are essentially some computer vision tasks, including object tracking, activity recognition, and the prediction. And today I will show you a little bit how deep learning methods can help with computer vision tasks. And we will use a simple example, object detection, as an example. So here's the outline of this presentation. I will first introduce some background and terminologies in case you are not familiar with this field. And then we will have our hands-on practice using object detection using deep learning models, and we will implement in Google Colab. And finally, if we still have time, we will discuss some potential applications in computer vision. So Before we get started, I would like to take some time to introduce a high-level concept about artificial intelligence, machine learning, and deep learning. And I believe most of you have heard these words many, many times, especially during the recent years. But do you really understand what these buzzwords mean? And what's the difference among these words and why it is so important? And why it's so popular, why we want to learn about that, and what can they do. And when I first stepped into this field, I feel quite confused because people usually talk about these words, they use them interchangeably without referring to their specific meaning. But conventionally, it is acknowledged that AI is a very broad field and a very broad concept. And in general, it refers to the machines that can have a human-like intelligence. And for us as researchers or engineers or future engineers, we want to make a machine intelligence. So AI is also referred to as the science and engineering of making intelligent machines. And here, the machines is not just a physical objects, physical machines. It's actually a very broad concept. It can be, for example, computer programs or systems, not necessarily to be the physical machines. And AI is a very broad field, so it has many subfields, including knowledge representation, reasoning, natural language processing, machine learning, and also computer vision is also a subfield of AI. And you found that machine learning is actually a subfield of AI. And machine learning is the ability for machines or AI systems to acquire their own knowledge by extracting patterns from raw data. And you may think it is approach to achieve AI, one of the approach to achieve AI. And then if we go one step further, in recent years or recent decades, so deep learning has become more and more popular and people talk about it a lot. So it allows the computer to build complex concepts out of simple concepts using large multi-layer neural networks, which is a term we use a lot in deep learning. So deep learning models, many of them is built from neural networks, and they have multiple layers of them to make them deep. So, and you may think deep learning is a modern technique to implement machine learning. And to give you some more intuitive idea about how it works, here is a high-level schematic. And in the first diagram shows you how the rule-based AI system works, and it's not machine learning-based approach. So in the rule-based AI systems, if I give you an input as a human, based on your domain knowledge and based on your experience or expertise, you may have some hand-designed program or some rules. Then you program those rules in the system, and system can make some decisions or make some output. For example, in our construction domain, if I use some sensors to detect where the workers are, where the machines are, then I may define such a rule that if the distance between these two entities is within a threshold, I will give an early warning showing there's a potential collision between them. That is a rule-based system, and it does not involve machine learning, which is like the program learn from the raw data. Actually, as human, we as programmer to define some rules, and that is one example of rule-based AI system. And second, one step further, if we want the system to be more intelligent, to be learned from the raw data or from the data, we have classic machine learning algorithms where we give you an input, and but humans still need some manipulation here to design some features to represent this input. And then This shaded box indicates the components that are able to learn from data, which means the machine learning algorithms will learn a mapping or function to map from these features to the output. It's just like if I give you an image that is represented by a collection of pixel values, and we will first design some features to represent this image, and then use machine learning to learn the relationship between the features and output. And finally, if sometimes tasks may just be so complicated that we cannot handcraft features that sufficiently represent this image, this input, or we may use deep learning. And you can see in deep learning, the idea is we can directly learn from the raw input data to learn this mapping to the output, and we do not need to use these hand-designed features. Rather, it can learn the feature representation by itself and learn this mapping to the output. Hopefully, that gives you an idea of what's the difference between among these concepts. And you can ask me questions if whenever you have them. And then let's talk about computer vision. So here I get this definition from Wiki because I want to give you an idea of the general concept of computer vision. So it is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. And from the perspective of engineering, it seeks to understand and automate tasks that human vision system can do. And the goal of it is to extract useful information from images. And we want the machines to be able to use the observed image or videos to infer something about the world. And if that is too abstract, here I will give you some typical computer vision tasks, and I'm sure you will be very familiar with those. So the first one, very typical computer vision task, object recognition or object classification. If I give you these two images, can you tell which one is chair, which one is table? So that is a task we want the machine to learn by itself and can give us the answer. And to recognize objects in the image. And then we may want even more, not only a chair and a table, but I give you this image or this scene. There are multiple chairs and tables and other objects in this image. And can the machine know what objects are in the image and where are they? So here you see there are actually two subtasks. One is to recognize these objects. The other is to localize these objects. So here you see we use a bounding box to show the boundary of these objects, the chairs, table, and umbrella here in the image. And we may find that is not so precise because you see some of this area does not belong to this umbrella, but we still use a bounding box to show that. So what if we want more precise results and we really want to differentiate the objects in this image? We also have image segmentation as another task. That is a pixel by pixel classification of the object, and you see it can show you the very precisely about the boundary of each object. And these are some typical computer vision tasks, and we have many more, including those I introduced at the beginning about my research. For example, object tracking, activity recognition, and prediction. Those are all computer vision tasks. Then you may ask, why you want to use deep learning to do the computer vision? Why is it so difficult? Because as human, we take vision as granted. So we feel it's so easy to differentiate between tables and the chairs. Why is it so hard for the computer to do that? Because in the real world is made of tens of objects, which may appear in very different shapes, poses, and appearance. And even for a single type of object, they have very different variations. And objects may be occluded by others, and there may be other factors affect the appearance, for example, the illumination issue. So for computers, they only take this image as a raw input data, which is represented by a collection of pixel values. So the function to map from these pixel values to the object identity can be very complicated. But deep learning deals with this challenge by breaking the design, by breaking the complicated mapping into a series of simple mappings. So here I give you an example to show this concept. If I give you an image and want to recognize the person in this image, from a deep learning perspective, the image would be the input data represented by a collection of pixel values. And then deep learning will have multiple layers of hidden layers to extract features from the image instead of we as humans to program the features. So for example, this one, given the pixels as input, the first hidden layer may detect some edges based on the comparing the brightness of pixels in the surrounding pixels. And then given the edges, we may identify some colors and contours based on a group of edges. And further, we may detect some object parts. So that is one step by one step to have these simple tasks. And finally, we can identify these objects. So that is the idea of deep learning. And here, in finally, we go to our hands-on practice, and then we will use object detection as an example. And because the model itself can be very complicated to be understood and to be designed. So here, as an introduction for audience like you from all background, I have prepared a code with a pre-trained object detection model for you to play with and to get some experience on that. So, but first I want to mention by pre-trained model, I mean, you can use this model to directly test an image that you find online, or we will also use webcam to take a picture or by yourself or other objects in your hand. So you will use this pre-trained model to do the task. But here I want to introduce three key aspects of pre-trained model. So first is backbone model. That is the deep learning model with different architectures used to recognize the objects. As here I introduced, that is the general idea of deep learning based object recognition. But nowadays, there are many popular deep learning models with these different architectures to use for the object recognition. And I will not go into detail about these models, but if you are interested in that, you can easily find all the information on the website. And remember, I said object detection actually have two subtasks. One is object recognition, one is localization. So we need to identify the bounding box for each object. So they have using different mechanisms or object detection algorithms, and these are some state-of-art object detection algorithms in this field. And in our pre-trained model, we will use some of them. And finally, the last part is the data side. The reason that you can use this model to train whatever image you find online is because they already trained on the public available data set that contains millions of images, which means this program already seen a lot of images and found the patterns behind that, so that it can learn to generalize to a new image that it does not see before. So all these three aspects will affect a model in terms of performance, for example, the accuracy and the speed of the object detection, as well as what object can they detect. So this data set are basically include images in common life. So if you just take an image in your home, it may work well using this pre-trained model. But if you have specific images in specific domain, for example, you have a medical image showing some body parts or other professional domains, it may not work well directly using the pre-trained model. And that's why this field is very active to solve those challenges. So without further ado, we can start our hands-on session. And here is a link using Google Colab. And I'm not sure if you've ever used that before, but I found that might be the easiest way to have this virtual session, because by using this Google Colab, you can directly run this program in your browser without any, and do not need to have any special configuration in your own computer. So what I'm gonna do is I will copy this link in the chat, and then you can open that in your browser, and we'll start from there. Chat. And I'll share what my screen shows. Let me know if you can successfully open that. And also I share this as view only, so you can run this program, but you cannot save your changes. If you want to save your changes, you can make a copy in your Google Drive so that you can work on your own version. Okay, let's get started. So because this is created by Google, so it's worked very well with Google Drive, and this Google Colab notebook is just stored in your Google Drive. And here's a table of contents, and I just go through the idea of this hands-on session. We basically have two parts. The first part is that we will use the pre-trained object detection model to detect objects in a random image, and you can search whatever image online you like to detect, and we may use different models, and we may change some parameters to see, and you may find when can they perform better, in what objects can they detect better, and in what objects they may fail. And the second part, we will use our webcam as the to collect some video streams from ourselves to show that real-time object detection using webcam, and that is more interactive, I think. So this program, this collab is adapted from to online resources. So one is from the official tutorial, one is another online resources, and I have put the original resource here. And if you are interested in that, feel free to find the original tutorials and the resources. So in case you are not familiar with this notebook, you may see that here are some cells with text descriptions, and those are just annotations. And the main code is in the cells with green colors, and the codes are grouped into different cells based on their functions. So when we want, we can just click this run cell to run this block of codes. Maybe a little bit, yes, low. So you see this, the first block is to set up our program. We want to import some important libraries. And here in this hands-on section, we use TensorFlow as deep learning library. And it is a very powerful and flexible tools, contains a lot of libraries in terms of machine learning and deep learning models. And it can be used to deploy your own model and applications. And some of you may use other platforms such as PyTorch, which is also a very good, powerful tool. But here I just use TensorFlow as an implementation platform. And you see here, if you successfully run this cell, it will show you that now you have a GPU device available, and that is why I think Collab is a very good tool for sections like this, because you may not have GPUs on your own computer or good GPUs on your own computer, and using this, you can get free access to the online GPU resource through Google Colab and without doing any configuration. And sometimes, trust me, the configure the GPU and all the program can be very time consuming and very difficult. So have all of you successfully run this block? Great. And then, so as I said, we use TensorFlow as a platform, and there's a Tensorflow Hub, and that is a repository of many trained machine learning models ready to use in your own application, or you can use that as a starting point to retrain in your own data. So we will use the pre-trained model from that, and this block is just to import all these libraries. And next will be define some functions and to manipulate the images. For example, to download images given a URL address, and to resize the image to be fit to the deep learning model, and you can just run that. Because of the time limit, we may not be able to go through all these functions, but you see the functions have very informative names. And if you have you are interested in, you can always go into into detail of these functions after this session. So they basically define some functions to draw the bounding box based on the object detection result after we perform that object detection. And then we'll collect this. This is actually to load an image from website. And here I just show an example. This is if you want to use your own image of interest, you can simply use the URL of your image to replace this and rerun this. And you will show different image. And we can do that later. Then assume this is image we want to do the object detection. And then remember, we need a pre-trained model. And here, there are two alternatives. One is, and remember, it is described based on the backbone network, this one or this one. They have two backbone networks for object recognition. And it's also different in terms of object detection algorithm. And these two, and they have different characteristics. For example, if you use this one, it can give you very accurate detection result, but that may take more time. But if you use this pre-trained model with different architectures and algorithms, you may get a faster result, but may not that accurate as the previous one. Here, I will use the second one, this one, because later I want to use that for the real-time object detection, right? So I will click that you see here is to load the pre-trained model. Next is just some other functions to load the image that we want to run. And this is function to determine how to run the object detector and how to draw the bounding box on the images. And let's run this. In the first time, it may take some time to load the image and load the program, and later it should be much faster. You see, here's the result. And this is one I actually used that in the slides, but a little bit different. And here, it says it found 100 objects, but why is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Why there's only 10 bounding box? So actually, and you see in each detection there is a percentage, right? That is the score for the detection, meaning the probability of this bounding box being this specific object. And we can always adjust this threshold for visualization and for the other decision making. Why? So sometimes you see actually this program, this model can detect many objects through this image, but some of them are with very low probability, which means it's not that reliable or confident. So we just want to show or use the result with high probability or high scores. So here we may change this minimum score to visualize, change this score to make it more confident about the results. And you can imagine if for example, you can update that. You can define whatever number you want, but the maximum is of course 1, right? That is the probability of the score. And you may find when I get a larger threshold, the detected object or the visualized result will be fewer. So once you upload this figure, you need to rerun this block. You see, no, there's no object detected. Why? Because none of them have the scores over 0.5. And it's this one is quite challenging, I would say, because there are a lot of objects and the scene is quite and some of them just in very close proximity, and some of them occluded others. So if I lower this value to 0.2, see what happens. You see those bounding box appears. And you may also change this one. This one shows you how many boxes or how many objects at a maximum will show in this image. If you put 5, it will give you 5 results with the highest scores. And if you shows 20, it will show you 20 because it has 100 objects here in total. So now I will give you some time to just Google an image of your interest and change this image URL to detect another image. And I'm not sure if this Zoom can upload the pictures or the files in the chat box, but if you want to share your result, feel free to do so. So how to find the image URL. I will say what image I want to find. I want to find a classroom, for example. And for example, I just use this one, and you right click and copy image address, copy image address. That will give you the URL, and you just paste here. See, and then rerun this block. You see here, I load that specific image. And now I want to run on the object detector on that image. And I don't need to reload the detector because it's already in this program. So I just run the detector. And you see, oh, it still has some chairs and tables. And these are very common objects in our daily life, right? But you see, it's not that accurate, I would say. For example, this table, the table in this row has not been detected. And the chairs, you see there are some offset of the bounding box. That's why we need to do more research, or we need to refine the methods based on specific application instead of just to use a pre-trained model. Any questions, or have you tested in a image found by yourself? And if you are interested in that, you can also change the model here, the pre-trained model here, and see if that model will work better in this image. It takes more time to load that model. Oops. I shouldn't start that one. Just don't stop. Oh, complete. So now, if we see this is the result of the previous model, and let's run the same image using the second model and see what's the difference. You see the inference time is much longer. The previous one only takes less than one second, but this one is about half minutes. But maybe it looks much better, right? Especially the bounding box, and it can detect this table. And I would say with a pretty accurate bounding box. Although it shows coffee table, which is not a coffee table, but maybe because in the training data set, they have a lot of table like this and labeled as coffee table. And you see, here is another table. And you see the different model architectures and different object detection algorithm will absolutely affect the final result, and depends on your application. If you want a more accurate result, then you can use some pre-trained model like this. But if you want a real-time detection result, real-time object detection, like what we will show later, so you may use the previous model because that is much more faster. So we will switch back to the previous one and go to the next part to use the webcam to take a picture or to have the live video stream to do the object detection. Okay, I load the previous model again. And now this part, we will just skip that. It's just to detect more image. But using the previous method, I believe you should be able to change the image of your interest. So now we will first still import some libraries. That is to create images and to address the images from webcam. So you will just run all these functions. And here, through this block, we will try to capture an image from our webcam. And for that, I need to turn off my video in the Zoom so that this program can access my video. So I will stop video. And then if I try this, you see, it shows my webcam, right? And for those of you who start this program at the first time, the browser may ask you whether to give access to your or give permission to your webcam, and you need to click allow. Otherwise, this program cannot get access to your webcam. And you see here, if I just capture, it will take a picture of myself, right? And also run the object detector on that. And it criticizes my face, like human face and glasses, and they show me this is a woman. So that is one example. And feel free to open your webcam if you have, and take whatever image you may take, holding something to take a picture also. So have you followed that? Are you all following? Because of this virtual session, I couldn't see your reaction, and great. Very good. And we will just continue that to see the live stream, the video stream, and later on you can play with this code after session. So we just run the next block to define how to handle the video stream. And here, I just want to show you this. So this is a real-time object detection, right? And in order to have this real-time object detection, you need a very fast object detection deep learning model, right? That's why I switched back to the previous one, because that is faster. Otherwise, you will see very serious latency between. But here, you may still see some latency. And now let me show if I see. It keeps detecting myself, maybe because, okay, I click here to stop. If I set larger number of bounding boxes and set a lower score, and to see what happened, if it can detect more objects. If I use some other, you see, it can detect my phone. It's not very stable because it's based on a frame by frame detection, which means what they detected previously will not affect the next detection. And so it's not very stable. And that's why if we want to track me to have very smooth trajectory, we may use object tracking to explore the dependence between frames. And if you can maybe you can use other. Oops, you see it's wrong. It says it's a camera. Oh, coffee cup. Yes, coffee cup. Yeah, I see the note. Typically, when it works pretty well in detecting human, because that is a very standard task, and we have many algorithms and many data to train the human detector. And if you want to detect some specific objects and that is not normally seen in the daily life, you may need to retrain this model or fine-tune this model. And yeah, that's pretty much about this hands-on practice session. And hopefully you enjoy that and have some idea on how these deep learning models or computer vision researchers have to do with our daily life and have to do with all of you. And hopefully you understand or have some idea on what can be useful. And finally, I just have one slide to give you some idea about the potential applications of computer vision, and I'm sure you should be. These are very important applications in our life. For example, video surveillance for the security purpose. We can detect human, we can detect we can understand a scene in the public space. We may be able to identify potential abnormalities or some threats. So for the public safety, video surveillance, human machine interaction, robotics, if you want to interact or use some assistant robot, how can the machines or the robots to understand your intention or understand your behavior? Computer vision is a very important approach. Inspection. So in civil engineering, we use computer visions to inspect infrastructure. For example, if the road, if the highway or the pavement has some defects, we can take pictures and to identify the defects, for example, cracks, potholes, etc. Autonomous vehicle, and I'm sure you might think about that. The autonomous vehicle is a very important application domain of computer vision, especially how the autonomous vehicle can detect pedestrians and can detect obstacles in the road, and that's very important. And of course, many more. And yeah, that's pretty much all this section. And I hope you may think about other applications related to computer vision or deep learning, and it can inspire your study and the research in the future. Okay, thank you. And if you have any questions, I can answer them.
Thanks, Janan. That was a great presentation.
Thank you.
I'm guessing the students have enjoyed the session.
Yeah, thank you. I'm glad they enjoyed it.
Any questions? You're a quiet group, guys.
So I have kind of a question more about like your research and like the construction like science part of it. So how important like because we talked about how you can have like a more accurate versus a faster model. Which one do you usually prioritize when looking at these like complex work environments? Is real time like something you go for to try to like avoid any like injury, or is it more like after the fact, like analysis of what's going on?
So in my application, I care, I would say both of them are very important, but near real-time application would be very important, because if you think about a safety issue, if it take you 1 minute or 2 minutes to detect any potential hazard, then that will be too late, right? So I may sacrifice some of the accuracy, which means there may be some but basically false positives, which I mean we may detect more alarms to make it safe instead of less alarms. So that has to do with the threshold. So you may need to adjust the threshold or adjust the model a little bit based on your application.
Thank you for answering that.
No problem.
Thank you.
Thank you.
Yeah, I think we'll start our next presentation in a couple of minutes with Dr. Rathore. If you all want to grab coffee, tea, or...
Yeah, I have both on my desk.
Yeah, or water break, yes. Yes, are you ready, Hina?
Yes, I'm ready.
Okay, it's like, is everyone ready? Okay, looks like they are back. Hina, the floor is yours. Go ahead and share your insights.
Okay. So thank you everyone for attending this particular session. I'll just open my chat window in case you have any questions. So the session title I have given as Collab AI, Accelerating AI Innovation Through Open Source Tools. My name is Hina Rathod. For those of you who don't know me, I'm in computer science department. My research expertise lies in developing security solutions for different kinds of cyber physical systems, which include smart home, smart Internet of Things devices, Internet of Medical devices. And I basically use bio-inspired approaches, which is neuro-inspired approaches. Machine learning comes under that, and other things to provide security solutions. This particular session is specifically on how we can have developed machine learning based solutions, how we can collaboratively work together, since we are in this online environment and we have to have a collaborative way to coordinate in different projects. So this particular session would be first, quickly, I would be talking about Git, then GitHub, then I will show you how to clone different kinds of machine learning repo, which is already available, different kinds of data sets which are available. Finally, how to make those changes. First, you clone those changes, how to make changes into that. And finally, I would be showing you all these demonstration. Before I run the overall session, I would like you to first confirm whether you have installed Git and you have Python and Jupyter Notebook installed. If you do not have it, what I would encourage you is, let me just share certain links with you. Meanwhile, when I'm talking about the background, please have Git installed as well as install Python and Jupyter Notebook. Okay, so let's start with initially what is Git in general, and then followed by I would be talking about GitHub and other thing. Meanwhile, please have your account set up on Git and have your software downloaded. Links have been shared on the chat window. So what is Git? Git in general is a very super popular version control system. It is a version control system allows users to keep track of the changes in software development projects. It enables them to collaborate on those projects, and you can collaborate on code as well as on different kinds of images on different kinds of project files, which could be HTML, CSS, JS, and other. Why Git is useful, or how Git is useful? Because of the three basic things, which is history, collaboration, and feature branches. History is, let us suppose that you are making changes. You are creating a Word document on your local computer, and you want to keep track changes to that particular Word document. Git helps you in doing this. Everything that Git does is on your local machine. Besides this, it also helps in collaboration. That let us suppose every one of us are writing a book. We are co-editing a book together. I wrote a piece of first chapter and I give it to you. And meanwhile, when I give it to you, my thing is frozen. I cannot make changes, because if I make changes, you have to basically either take the latest copy, or whatever edited version you are creating, you would have to send it back to me. So it helps in collaboration. It makes more productiveness. Besides this, it also helps in feature branches. Let us suppose if there are separate tools or separate sections that each one of us are working, we can create branches. Branches could be considered as a tree, a branch of a tree where a main branch is there, as well as there are like separate other branches where you can make other changes. And finally, you can merge those changes into the main branch. So this helps in these kind of things. There are various popular version control system: GitHub, GitLab, Beanstalk, AWS, and other. In this particular session, we will be covering GitHub. GitHub is a very popular, I would say, it's a web interface, and it is a software tool to collaborate and maintain the entire history of the code changes. Why do we learn Git? Because it's an industry standard. Most of the company looks at it. And where do we begin? We will see how we can begin with it. But before that, let's talk about GitHub. As I said, GitHub is a web interface for Git changes. As I'm making any changes and you are making another change on your machine, we can collaboratively push it on the cloud, which is maintained by GitHub, which is a central repository of maintaining all the documents and other things on GitHub. And Git is different than GitHub. Git is maintained on our local computer, and GitHub is a web interface for Git where we can collaboratively work together. Besides this, there are certain basics that you should know before I jump into how we can use GitHub. A repository, branch, staging, commit, push, pull, request, and merge. And we would be doing some of these today. Repository is I would say it's like a folder on your machine, which could be anything which contains images, which could be files, other thing. It's a working directory. There is a concept of branch, which is a workspace where you can make changes that don't affect the main thing. Let's suppose if you see this particular figure, there is a master branch where everyone makes the changes, and there is a feature branch, which is another branch where you can make the changes. And these are separate two copies. Once you have made all the changes on your machine, you submit a pull request, and that pull request, you merge it back, you pull that request back to the main branch, and finally you merge those changes. And finally, there is a single copy which can be maintained. Overall, branches can be helped in keeping different track in different working together. Like let us suppose I am working on the header section, you are working on the footer section. We can create separate branches. Besides this, there is a staging concept. Staging is preparing and getting ready. And for this, there is certain amount of commands that we can use. There is a concept of commit changes. When you have made the changes, then it's Git's way of saving. Finally, we push or pull request. Push and pull is different in such a way that when you say pushing means that you are from your local computer, you are pushing the changes on the GitHub. That is push. And pulling is pull is opposite, which means that from the GitHub, you are pulling the latest changes to your local copy. So these are two other concepts. We would be doing pull request, and finally, we can merge the changes once we have submitted the pull request. So these are some basic requirements or basic concepts that you would be requiring in order once I jump into the hands-on training. Okay, now let's talk about, as Dr. Janan has also talked about, artificial intelligence, machine learning. A very quick introduction that artificial intelligence has revolutionized in different aspects of research and industry, whether it is autonomous, whether it is healthcare, whether it is robotics, whether it is NLP. You saw object detection was one of the things in the previous session. So it has been worked around at different ways. If you have to look around machine learning, which is a sub part of artificial intelligence, machine learning can be divided into three basic learning: supervised learning, unsupervised learning, reinforcement learning. Supervised learning contains, like, everything which is being done is on data set. You should have ample amount of data set in order to train. How do you learn from that data set is through this learning mechanism. Unsupervised learning is a learning which is based on when there is no labels, there is just data which is available, and you make an inference out of it based on clustering algorithms and other algorithms, which is finding the similarity between the two kinds. Let us suppose that we have to check whether it is an apple or not. You would be calculating the difference or similarity between the different kinds of objects that is already available. That is unsupervised learning. There is no labels. You make an inference. Supervised learning is another kind of learning that happens. And in this case, you have a label associated with your data set where you have the data and you assign some labels and you learn through different kinds of, I would say, the learning is performed by an example. You say that this this kind of structure is what is apple. If it is an orange, this would have another kind of structure. You assign a label to it. That is supervised learning. In this particular session, we would be doing supervised learning, where you have data and you can assign label, and finally you make an inference out of it. Reinforcement learning is another kind of branch, and in this is very upcoming branch, and presently I'm working on reinforcement learning, specifically taking inspiration from human brain side in order to have, I would say, learning through brain reward systems. Here, reinforcement learning happens with the experience. Here, like, let us suppose you just give the data and you make an agent has to learn based on, the goal is to find any kind of, I would say, learning by experience. You just explore the world and try to learn. There is a rewarding scheme that has been added in order for the system to learn. So besides this, a very quick, I would say very quick introduction to machine learning, like how this overall system works is it's divided into 8 steps, where you take the model, you forward propagation, there is a loss function, there is a backward propagation, there is a weight update, and finally you iterate until the convergence. What happens is, let us suppose if I give you this kind of data where you have an input and you have an output, and you have to check what is the relationship of the output function with respect to the input function. So if I give you this particular problem, can you tell me what is the inference of the output with respect to input? Is there any relationship that you can draw out? Any yes, so the input the output is the input is the output is just the double of the input. So 1 is 2 is 4, 3 is 6, 4 is 8. So how this machine learning model works is that you calculate the overall model is to find the actual versus the predicted relationship, whatever is the actual and the desired. So here, let us suppose the first machine learning came and said that it is just the thrice, and the actual output that we got was 3, 6, 9, but the desired output, what we wanted, was 2, 4, 6, and 8. What we do is we calculate the absolute error, and that absolute error can be, we look at the squared error, because higher the error, more should be the square error. We calculate the difference between the two, and if this difference is very less, either we increase the weight or we decrease the weight. Once we increase or decrease the weight, we check whether we are reaching to the local minima or a global minima. When we calculate the difference between the two, which is actual and predicted, comes out to be very small, which means your model is overall trained, and this is how you would be training the overall system. So this is basic machine learning model, and we would be there is a code that is available, and you would understand why I showed you this particular example. Finally, as I said, there is a weighting mechanism. You said give a lot of inputs. These inputs could be anything where you are learning the model. You assign certain weights to it, to all these inputs. You add them. Once you have added them, you can introduce non-linearity into the system, or you can say there is also a bias which is attached, which helps you in the activation function. And finally, you calculate the desired output. And this, as I said, the desired output can be dependent on the difference between the actual and the desired. And there are various activation functions that you can apply based on the model that you are learning. Okay, so I first described GitHub. I described machine learning. One last thing, which is data set. And once I have described this, then I'll directly jump into the training. So before we jump into the training, everything, as I said, machine learning learns from the data set. Where do you get this data set? This data set can be openly available, or you can have your own data set where you want to train. So if you would look, the data set can be divided into 2 types, which is structured data, and the other one is unstructured data. Structured data has a particular schema. The schema could be date, time, and there is a proper structure. What is the label and other things? It's a proper structure which is arranged. That is structured data. There is unstructured data, which could be images, files, and other things that comes under unstructured data. There are various open source libraries, I would say platforms available where you can capture this data set. Besides this, there is another new concept, which is data lake, which is out there, which is based on taking the data from the system, or it could be structured or it could be unstructured data set. You apply some machine learning algorithm, and finally, after applying machine learning algorithm, you get the inference out of it. And this is what we would be doing today in terms of taking the data. Warehouses and data warehouse is another concept, which is just applying data analytics on the data, or I would say structured data that is available. Okay, now let's directly jump to the session. For that, what I want you is, let's first go to GitHub. So I have created a repo, and I will just share this particular repo with you. Let me just make this as so let me post this particular URL in the chat window. So 2 URL I am posting, and I would want you to access those. Okay, so first link is a Google Cloud platform, and the other one is the Tinker with AI Git, and that is what I have created. So I would want first you to click on the second link, which is github.com Hina3443 Tinker with AI.git. Once you do this, I would want you to we would be playing around with this, and we would also be playing around with the Google Cloud Platform thing that I would be saying. Okay, so if you click on the second link, which will open the Tinker with AI, if you click on this first link, this is the Google Cloud Platform. So as I was saying, there are several data sets which are available online, and you can access these data sets based on your, I would say, learning wherever you want to do. So let's suppose if I do Google Cloud public data sets, these are some public accessible data where you can play around. So if I click on explore data set, you would see there is a COVID-19 public data set. So we will play around with this COVID-19 public data set. For the second link, the first link that I shared, which is Google Cloud Platform, here there is this what is the prediction of the baby weight, and we would be playing around with this. So for this, what you need to do is open your command prompt. In order to open command prompt, you would type CMD on your Windows. If you are using your Linux machine, you will open the terminal. Once you open this terminal, we would write certain piece of line of code in order to access these 2 repos. Okay, so once you open this, you can click on PWD. PWD tells you where is your present working directory, where you are presently at. Okay, once you do this, what I want you is to clone the first repo first, which is this Git, the cloud one. So for this, what you will do, you will write git clone and then paste the URL, which is this HTTPS. Once you do this, it would make a clone of this copy. So far, everyone is following up. Are you doing this particular exercise, or am I going too fast? Is everyone following up? Okay, good. So now, since you have cloned this, what you would do, you can go under your C drives, users, and this is under Hina, and you would find that it has been cloned under the name, which is ML design patterns. So this is the ML repository which is being copied, which is cloned on your local machine. Now, what I would be doing is I would be accessing, there are several already available, some codes that are available. I would be accessing one kind of code over here. So for this, since I said that you need to have Jupyter Notebook installed, if you have Jupyter Notebook, what you would write on your command window, you would write Jupyter Notebook. And as soon as you would write it down, Jupyter Notebook would open to the same the present working directory that I have. And if you would see, this is the ML design patterns, which is being copied over here. Now, I would be going on problem data set, which is 3, which is problem representation. And I would be clicking on the reframing exercise. So if you click on the reframing Python library, which is, there is already code that is available. What we would be using, as I said, we are using Google Cloud Platform to access the available machine learning code as well as the data which is already available. And this particular data set is on the birth weight prediction of the birth, the baby's weight who gets into the who gets newly born. So what I would be doing is, if I run, this is the history which is already stored, but once you will run it on your local machine, you would get an error. The reason being because the Google Cloud Platform requires the JSON file, and that JSON files helps you to access your account on Google Cloud Platform. So if you go back to Tinker with AI, the second link that I have posted, there is an instruction on how to create a key so that you can access the code. So what I would want you to is click on this second link, which was Tinker with AI, and there is this service account page where you would be clicking onto it. Once you click on to this, you would find, you would have to log into your Gmail account. Once you click on your Gmail account, you would be asked to create a JSON file. And in order to create a JSON file, what you do is you first create the project over here and type down the name as Tinker with AI. This would be a new JSON file that would be created. Once you, since I've already one, I will just write with Tinker with AI 1. I click on create, and it would take certain amount of time to create this particular project. So once, is everyone doing this with me, or you're just following what I'm saying? Here, I have the instructions is once again on the, I would say, on the GitHub page that I shared, which is Tinker with AI. The instruction is how you would be creating. If you are not following up, I would want you to just look through the steps, and I would encourage you, because this repo has already been created, and I would want you to try this once the session is over. But anyways, once you do this, you would be having the account. Where is that account? This is the service account, and I created that service account. So I would just write here as Tinker and nothing else. I would create. And once I have create, I click on done. I have this particular JSON file that I have to create a key out of it. So I will click on it. Once I click on it, it would ask me to create a key, and I would create a key, and that would create the JSON file that would help me in running the code. Once again, as I was saying, this JSON file is required to access any of the global data set, Google data set, which is available, to apply some kind of BigQuery algorithms onto it, and then we can write machine learning codes onto it. Once I have done this, this is the new JSON file which is created. What I will be doing is, this is that JSON file, Tinker with AI 1. I would rename it because the code is already available. What you will be doing is, I have the JSON file is already available. So I'll go back to my C users cleaner, and then I will go to the ML, where is that ML design patterns. And here was the problem data set number 3, and I will post that particular file over here, which is JSON. Once I have done this, what you would be required, the steps, as I'm saying, the steps are already available. If you are going little bit slow, I can slow down, but the steps are written over there. Once you have done this, you will copy these 3 lines of code. This is just importing that JSON file. And once I copy this, I would be posting it over here where I'm importing the files. Okay, these are the only steps that you would be required to run the Jupyter Cloud platform on your local machine and to use the global public data set which is available. Okay, now once you have done this, what I'll do is in the Jupyter notebook, either I can restart the overall session or I can clear and restart it. So I will say restart and run all. Once I click on restart and run all, now the program would be running step by step. Each cell would be running and we would be having the output in this case. So if you would see cell number 1, what it does is it imports the different kinds of libraries. NumPy is used for performing different kinds of, I would say, predictions on mean, calculating the standard deviation and other thing. Seaborn is another library which is used to create visualizations, and we would be using the Seaborn. BigQuery is used to access the global public data set which is available under Google. So I have imported. I have also imported the matplotlib to see the pictures and other thing. And I just wrote down with the Tinker with AI GitHub, I had copied these 3 lines of code you have to copy in order to access your JSON file. Once again, I will say that these JSON file, it's a BigQuery requires the JSON files to access our accounts through the Google platform, and that's the reason we require this key. Once you have done, I open the BigQuery on my client machine, and then this is the BigQuery that this is written. What this BigQuery says is you are accessing the public data set, which is for birth control. It has different columns. It has weight pounds. It has a column is male, gestation week, mother age, plurality, and the mother's race. The mother's race has been given 1, 2, or 3 label, which basically tells what is the race of that particular mother. So I am running a BigQuery which says that I want to access all the data set where the baby is a male. The gestation period of a mother is 38. The mother's age is 28. The mother's race belongs to one category, which belongs to race number 1. And once I have done this, I am accessing the data set which is available on the global, the Google platform, and I want to print all the data sets. So I'm using a data frame to access the public data set, and this gives me the output over here. Once I have accessed this data set, I am using the Seaborn to calculate the probability distribution or the Gaussian distribution of the baby weight. So if you would see in this, this distribution of the weight of the baby, where the gestation period was 28 and gestation period was 38, the mother's age was 28, another thing, the probability distribution is this, which means, or the Gaussian distribution is this, where I can use the NumPy library to calculate the mean, and the mean is 7.48, which is of the baby. The standard deviation is 0.989. The same query which was written earlier, I have modified into, I have modified, the Google Cloud platform has modified, where now it has written the same query, but in this case, the number of gestation period of the mother is 36, the age is 28, and the rest of the thing is same. You would see the difference over here. The mean now is 6.70, which is the weight of the baby. In the previous case, it was 7.48 when the gestation period was 38. So this is the normal inference that you can do it. As I'm saying that there are several programs that are available under this ML design patterns. Once you will download it, the only requirement that you would be doing is to incorporate this JSON file in order to run this on your machine. You can play around with the different codes that is available. I am trying to give you one particular use case, which is for the classification and regression. So this, the initial thing that we just learned is getting the inference out of it. So everything over here, the data you are accessing is from the cloud platform. What if where you do not have like good storage system? In that particular case, you can use the Google platform to access this data set. But now let us suppose you want to download that data set, and now you have to infer certain kind of, you can do a classification problem or a regression problem to do it. So for that, what you can do is, if you have copied that file, I would say if you have cloned the ML design patterns, there is also a data. Here you would see this is the CSV file, which contains all the information, which is what is the weight, if the baby is a male or a female, what is the gestation period, what is the plurality, and this is the CSV file, which is just there. You have on your local machine where you have good amount of storage requirement. In that particular case, you can run the similar kind of code, but this time you want to do a classification problem. So as I'm saying, the code is already available over here. Initially, you import all the necessary libraries, NumPy, Pandas, TensorFlow is a library which is available to have your machine learning models already available. You are using Pandas to access the CSV file, which is that baby weight train file, which is the CSV file which contains those features. Now what you are doing is you are assigning certain labels. So if you recall, I had mentioned there are three kinds of learning: unsupervised, supervised, and reinforcement learning. In supervised learning, there is a data set which is given and you assign certain labels. So in this particular program, we are assigning a label to do a categorical classification problem, or I can say regression, where you want to predict the weight of the baby. So if you would see, I'm assigning the label, which is when the weight of the baby is less than 3.31, then assign label 0. If it is between 3.31 and 5.5, assign label 1. If it is between 5.5 and 8.8, assign number 2, else return 3. So there are three labels that you have assigned, 1, 2, 3. And then I'm just printing the data frame once again. As you recall, in the previous one, it had 6 columns, which was weight pounds, is male, gestation week, mother's age, plurality, and mother's race. In this particular case, now it has 7 columns, and the 7th column is the label that is being assigned to this data set, where I want to classify based on the weight of the baby. Now what we have done is any kind of machine learning algorithm requires training, and then we test the overall data set. So what we are doing is we are dividing the data set into 80% and 20%. 80% is used for the training and 20% is used for the validation. And here, once you have divided, we divide the overall data set into 2 problems: classification and regression. So I'm using the tensor slices to divide the overall data set to have 2 kinds of problems. One is classification and the other one is regression over here. Once it has divided into the 2 types, we are accessing all the categories, which was, if you would look at it, mother's age and gestation age is the only one which has the numbers. Weight pounds is male, plurality are the ones which are not numeric. These are either strings or either it is a float number. So that is why we have numeric columns which with the mother's age and gestation age as 1, and categories which is having string and other things in the different. Once we have done this is feature extraction, which is basically we are taking it as the input features. We put these input to the model. by creating the overall model. As I said, there is an input. Once you give an input, you assign certain weights, you put it inside the hidden layer, and after the hidden layer, you put it as the output. So this overall program, this particular cells is creating the model, which is taking all the inputs, which was the 4-5 inputs that we are taking. We are taking 2 hidden layers. The first hidden layers contains 20 neurons. The second hidden layers contains 10 neurons. Once an activation function, which is being used over here, is rectified linear unit. Once we have done, once again, we have 2 problems, classification and regression over here. And in this case, we are, once we have modeled, we are training the data set by using the fit function and the evaluate function in order to train the overall system. Then once we have done, what we are doing is we are using a prediction function to, in order to, for both the classification and the regression. Regression would be giving you a single input, single output. The classification returns the probability distribution with respect to the weights which are being given. So if you would see at the end, what we are getting is the baby's weight prediction, which is based on a particular weight. What is the probability? The weight of the baby would be 7.307. What is very, and this is classification plus regression. So it is basically telling you what is the probability distribution of a baby to have 7.300 weight, and whether it is very low, low, average, and high. Okay, so this is what we have done on the already available data set, which is on the Google platform. Okay, now what I want you to do as an exercise is, if you have understood all of this, is to go back to the Tinker with AI. And what I want you to do is clone this Tinker with AI on your local machine using the same kind of thing. So let me just stop the this Jupyter notebook. So I'll stop this Jupyter notebook. I will do Control-C, and I would be back on my working directory. I would clone the Tinker one, which is this repo, Tinker with AI, which I have posted it. So you would just click on copy this, and you would paste it over here. Once you have done this, you would be having on your present working directory, you would be having Tinker with AI as the program which is available over here. I have already copied a gcp.json file, and that is for my machine. Once this session is completed, I'll just remove it. So because it's very vulnerable, you cannot put the key of your personal machine on the cloud server. But the steps that I showed you, you have to follow those through those steps, and you would copy that JSON file on your local machine. Once you have done this over here, if you would see, there is a Git hidden folder which is created, which will keep track of all the changes that you are making. Once you have done, there is also this tutorial 2.ipynb, which is a Jupyter notebook. And in order to access that, you would just write Jupyter notebook, and it will open, and you will come to your Tinker with AI Git, which is there. And here you will open the tutorial to the data set over here. So in this particular code, it is very similar to the previous code, which was for baby's weight, but this time the code is for COVID-19 data. This data set is once again taken, it is taking into consideration the data which is available on Google Cloud Platform. And that is the reason you would have to write these 3 lines. Since, as I was saying, for the demonstration purposes, as well as for the hands-on training purposes, if you have cloned it, this you would be having the similar kind of cell in your machine. But once again, if you would be running, I will be removing the jcp.json. Once this session is finished, you have to paste that JSON file back into this folder in order to run this. So here, once again, what you would be doing is, the first is the cell which is importing all kinds of library. Then you are using the big query to open that JSON file. And this query is, what this query is doing is it is accessing the public health data, not the health data, but the COVID data, which is giving you what is, you are selecting the data set where the number of people who got confirmed, like who got COVID in June 2018, like how many of them got in 2018, like in June. And once you access it, you would be, you are using the data frame to print the overall data set over here. And you would see that Qatar in June was having total amount of, I would say, COVID patients were 97,000 in, and over the population of this, which has the case percentage of 3.41. Similarly, we have different other countries, and all the other countries were having these confirmed cases. Once again, I'm using Seaborn. If you recall in the previous example where I showed you the Seaborn, we are using the Seaborn in order to access it. And in this case, it gives you in June how many people got, what is the case percentage of people who got COVID. And you would see that in Qatar, it was 3.5. The case percentage was 3.5. The only country which was having the maximum one was Qatar, but the rest of them with zero, there was no COVID cases, were nearly 101 countries. The other places where the amount, where the number of COVID patients was fairly less, but Qatar had the maximum. So this is just for the representation of sharing that data set. Once again, we are accessing the data set which is available on the Google Cloud. And this is another Seaborn exercise, which is taking in the country code of different places and telling you what is the amount of people who got different kinds of who got COVID in June. And country code is for each of the country which is giving that. There was one country which had this many cases, and that was Qatar that time. Okay, so for your assignment purpose, what I want you to do is, you need to do certain amount of exercise over here, and either you can follow through the steps that I'm doing, or you can just do it once this session is finished. I just have 5 minutes, so I'll try to wrap up soon. But what you would be doing is, you need to create a new branch. So as I was saying, how does this GitHub works is that you start with the main branch. So and you create a sub branch where you make the local changes. So let's suppose that I cloned a repo, and that repo is stored on my local machine. That is the main branch. One way is that I can make all the changes on this main branch, or what I can do is, a good practice is that you create a sub branch, and in the sub branch, you make different other changes. Once you have done with these changes, you submit a pull request. And once you submit that pull request, you merge them in the main branch, so that now the new copy would be having the latest updated code. So as I had copied the code in my main branch, this was available. Let me just do Control-C to stop my Jupyter notebook here. Let's close this. And here, okay. So it closed. So these are the steps that you would be doing in order to make certain changes and then push back certain changes. So for your assignment, as I was saying, you would, once you will click on this tutorial to, this is already available. What you have to do is create a new branch on your local machine. So in order to do this, what you will do is you will say, first you go to the Tinker folder that you have created. not created, but you have cloned. Once that has been cloned, you will create a new branch, which is git branch, and let me just say branch 2, or let us suppose branch 3. Once I have done, I have successfully created a new branch from my main branch. Now I want to go to the branch number 3. So what I'll do is I'll say git check out to branch 3. Once I have checked out over there, what I will be doing is let me open my this Jupyter library, which is tutorial 2, and I have to make certain changes. So for the assignment, what I have asked you is to write a query to take this, and this query you can find from this link as well. Like the output you are there, like which is available there. Once that query you have taken it, you would be posting it over here. Once you have done these changes, you would be pushing those changes back to the GitHub. So let us suppose I open my Python library once again, the Jupyter notebook once again. So this is my Jupyter. So I'll just go Jupyter notebook, and I'm not making many changes, but I'll just make one change and I will push that particular change. So here is the the tutorial 2, and let me make just one change saying that I'm done with my changes. I can give you the code as well, but the link is already over here. So this is done. I save it and I come back to my GitHub over here, and I will click, I will check Git status to know if there is any changes, being done. And you would see, since I have made changes to tutorial 2 the Jupyter file, this is what it is showing me, that there is this particular file that has to be merged, that has to be changed, that has to be pushed back over here. So what I'll do is since I have already made this change, what I'll do is I'll say git add tutorial 2 .ipynb, and this, once it has been added, I will do commit to make secure that this is what I want to save it, -m, and then followed by just added one line. Once this is done, what I'll do is I'll push this change. So I'll write push origin and git push origin, and then branch 3. This is what I want to push on my GitHub. So if you would see under GitHub here with the repo that I have created that you would be using, here presently it has main branch and it has branch 1 and branch 2. Now I want to push the branch 3 that I created. So what I will do is I will say push git push origin branch 3. So as soon as I do this, it gets pushed to my GitHub, and you would see that under GitHub there is this branch 3 which has been already created. So I would click on compare and pull request, and this is what you would be doing on your local machine. You would be making the assignment that I have posted you would be writing that particular query. You would be pushing that onto this Tinker with AI public repo. Once you have done this, I would be getting a pull request on my side, and I would be making updates. I would be making changes by pulling that particular request, and I would be merging. As I said, there was a pull request. You create a branch, you submit a pull request, and then once the person who owns that would be merging it, or you can basically assign it to any person who wants to merge these changes. Once that has been done, I would say confirm the merge. And once this is done on my machine or on this repo, if you will open this tutorial 2.ipynb, you would see that in the end, I see this particular change that I had made on my local copy. So this is what I wanted to show on this particular session. As I'm saying, this is one assignment that I would want you to do it on your machine, like once this particular session is finished. But the overall agenda for this particular session was that firstly, I described you. I know if I had been if I was too fast, if you have questions, I can answer them immediately. But what the sequence process was, I initially started with Git. I explained to you what is the usage of Git. Then I talked about GitHub, how you can create a repo for collaboration. Once you open a repo, and I didn't show you how to create a repo, but you can create a repo. But what I showed you is how to clone a repo from the globally accessible repos that are available. Once you clone them on your local machine, you can make changes to those to that particular code. I also showed you how to access data set from Google Cloud Platform. There are several data sets also. There is a UCI machine learning repository. There is a Kaggle data set, but I specifically chose Google Cloud Platform for, I would say, storage purposes, because for those machines who do not have enough storage, we can just access the data set which is available on the Google Cloud by running the BigQuery. In order to run the BigQuery, you should have a JSON file, which I showed you certain steps. So you would have to do those particular steps in order to run access the data set which is available. Once that has been done, how you can write machine learning algorithms on it. Right now, I had given you a basic exercise on just writing down the inference. Once you have done this, how to create a feature branch by on your machine, how to clone firstly, then how to create a branch, then how to push that particular branch back onto the to the GitHub. And once you push it, I would be able to do the pull request and finally merge the request. So by the agenda, so the end of the key goal of this particular session was to explain you how you can access the AI, or I can say the data set which is available, how you can write machine learning algorithm, and finally how you can collaboratively work together if you are in an online environment. Okay, so that's all. If you have any questions, I'm here to answer. If there was any step that you did not understand, once again, I will repeat, please do the particular simple assignment that I have given you so that you get a better understanding. If you have any questions, you can always reach out to my email address, which is hina.rathor@utsa.edu. But if you have any questions right now, I can answer that. Thank you, everyone. Any questions?
I have a question about how you split up like the training and the test data. Is that like, is 80-20 like a standard, or does it depend on like the model or like what you're trying to do?
So it all depends upon you. Normally, it's a good practice to have it more amount, the large amount of data set for training and less amount for the testing purpose, because the more you train your overall learning algorithm, the higher it would be accurate. But it all depends upon the person who is creating. So normally for my use case, I generally do 60-30 and 10%, which is 60% for the training, 30% for validation, and next for the testing purposes. But as I said, you would see different machine learning codes available that has different kinds of division in terms of testing and training.
Sounds good. Thank you.
Any other questions from the group? Awesome. Well, Dr. Rathore, thank you so much on the behalf of Dr. Kudathapudi. Unfortunately, she had to leave a bit early. Thank you to both of our presenters and our attendees as well. We really appreciate taking the time to join our event today. So with that, we'll conclude. And as Darisha mentioned, we do plan to run a few more of these throughout the summer. We will use the email addresses that you provided as part of registration to follow up with those. So thanks again to our presenters, and have a good day.
Thank you. Bye.
Thank you. Bye.